Hi, welcome once again to Domoji Math and Science. In today's lesson, we'll be taking a look at projectile motion formulas. We'll see how to derive these formulas and also how to apply them. When an object is inclined, is thrown upwards, let's say an object is thrown upwards, it definitely forms a parabola. It forms a parabolic motion. Now that object is actually thrown at an angle. Let's call that angle theta. Now, there are some unique things I want you to observe first about this object. Now, the first thing is one, the object forms a parabola. It forms a parabola like this. That is, it forms a parabola. Number two is that this angle at which it is thrown with an initial velocity of u, and this velocity can be resolved into two major components. That is, it can be resolved into the y component, let's call that our uy, and it can be resolved into an horizontal component, let's call that our what? Our ux. Now, from our Pythagoras theorem, we'll know that your uy, if this side is uy, you know that uy over, and this is u, uy over u is equals to sine theta. So that uy is equals to u sine what? Theta. And ux over u also is equals to cos theta. So that ux will be equals to u cos theta. We have done a lesson on Pythagoras theorem. We will include a link in the description below to help you in case you need a lesson on that. Now, this is the second thing. This is 2. Now, the third thing I want you to understand with this set of motion is that the motion it's a motion under gravity. So, since it's going from u to v at this point is going to be 0. V at the highest height here is equals to 0. Now, since it's going from u to 0, the velocity is reducing, therefore it's under a negative acceleration. And this acceleration is due to gravity. So that the acceleration A for this particular set of motion is going to be equals to minus g. Is minus g. And finally, the first thing I want you to remember about this motion is that the v at this point is equals to 0. At the highest height, the v is equals to 0. So knowing this, remember from our first lesson where we dealt with the equations of motion, we said that if v is equals to u plus at, now from here, it's obvious that my v is 0 is equals to u plus at. Now, if I'm going upwards, I am moving under the vertical component of u. So that I'm saying that 0 now is equals to uy plus at. Remember that we have said that uy is equals to u sine theta. And we've also said that a, since it's going upwards, a will be the same thing as negative g. So that 0 now will be equals to u sine theta minus gt. So that minus u, transferring u to the other side, u sine theta becomes minus u sine theta is equals to minus gt. So if you divide both sides by minus g, divide this side by minus g, we're saying that my u sine theta will be the same thing over g is the same thing as t. Now this t is a time to reach this maximum height. But when I'm thinking of the time to complete the whole journey, it becomes times 2. So that my capital G, t, will be equals to 2u sine theta over g. Now that's the total time taken to complete the journey. Now let's look at the height of the journey. Remember our third equation of motion says v squared is equals to u squared plus 2as. Now, if v squared is equals to u squared plus 2as, now we're talking about our s now is the time taken to reach the maximum height. Let's call that h. And our v squared, our v at the maximum height, remember, is equals to 0. So that 0 now is equals to u squared. Our u now is the y component of the u, all squared, plus 2 into our g, our a is negative g, and the s here is the height. I said let's call it h. So that 0 now will be equals to u sine theta all squared minus 2gh. Now, so that we said 0 is equals to u sine theta all squared minus 2gh. So that let's u squared sine squared theta come to this other side, it becomes negative, is equals to minus 2gh. Minus cancels minus, and I can still divide both sides by g. It's, we said capital H all over 2g. 2g cancels 2g, so that I'm left with u squared sine squared theta over 2g to be equals to h. Now, so if u squared sine theta, now let's take a look at the horizontal movement, that is the range. Now, if this is the parabola, let's look at the parabola once more. Let me just draw it for clarity's sake. Remember that this is that's the angle permits my drawing, angle theta, and we're talking about the range, which is, let's call that r. Now, if the range is r, now for this particular motion, we'll be talking of the x component of u, and ux, which is the x component of u, is equals to u cos theta. Now, also remember that for this motion, it's not going to be under gravity. Our g in this place will be equals to 0, which is equals to our a is equals to 0. Now, let's still go back to our formulas. Let's use, if s is equals to ut plus half at squared. Now, because there's a concept of time, it's the motion would have gone through it under the total time t. Time t is equals to 2u sine theta over g. 2u sine theta over g. That's the total time for the journey. Now, so our s now is equals to r, which is the range. That means r now will be equals to u. Our u is the ux component, that is u cos theta, into u 2u sine theta over g, plus half. Now look at this, half times a. Our a is g, and g is equals to 0 because we're looking at the horizontal component of the motion. A is equals to 0, so the whole of this is equals to 0. So I don't need to think of that any longer. So that your r now will be equals to 2u squared cos theta sine theta over g. Let's remember from our trigonometry that our 2 from trigonometry. Let's remember that 2. Let me just write that here. Let's remember that 2 cos theta sine theta is the same thing as sine 2 theta. So I can rewrite this to mean u squared times 2 cos theta sine theta over g. So that my r finally will be the same thing as u squared sine 2 theta over g. So with that, we have given expressions to that r. Now let's take a look at, let's use this example to further understand it better. So that a ball is projected at an angle of elevation of 60 degrees with an initial velocity of 100 meters per second. That means u is equals to 100 meters per second. Because it's a projectile motion, we have the motion this way, is projected this way. U at this point here is 100 meters per second, and v, which is a maximum velocity, the final velocity, is equals to 0 meters per second. Now calculate the time of flight. Now the total time of flight for this, we can simply plug it into our equation, that t is equals to 2u sine theta over g, which is equals to 2. Our u is 100. Then our sine theta, that's the sine of 60 degrees over g is 10. 10 here is 1, 10 here is 1. Then that becomes 2 times 10, that's 20. Sine 60, sine theta, that's the sine of 60, that's 0.866. That's times 0. You can do that on your calculator, 866, so you use root 3 over 2 for sine 60. And that's equals to 20 times 0.866, that's 17.32 seconds. That's the total time of flight. Now the maximum height reached h. The maximum height reach h, we can always get the maximum height reach from our formula also. You can just plug this into u squared sine squared theta over 2g. That's equals to 100 squared, that's u squared, that's 100 squared, sine squared theta, that's 0.866 all squared. You can plug that into your calculator and you will get the same thing as our final height, which is 375 meters. 375 meters. You can also calculate the range covered for this particular question. Squared sine 2 theta over g, which is equals to 100 squared sine 2 into 60, that's 100 sine 120. Now you can use your calculator once again to derive your sine 120. This 100 squared sine 120 over 10. 0 here. Okay, let me just bring out the full expression, trying to manage space. That's equals to 100 times 100 times sine 120. Let me just quickly get this from my calculator. Divided by 10. I'm left with 1000. That's equals to 1000 times 866 times 0.866. Obviously, that's 866 meters. Okay, thank you for staying with us and do have a nice time. In case you have questions, please do not hesitate to use the comment section and we'll be there to answer your questions.